In science, we often find ourselves multiplying, dividing, adding, and subtracting various measurements. Specifically for this video, we're going to be talking about multiplication and division rules for rounding when we are using multiple measurements together. The general rule of thumb is that when measurements are multiplied or divided, the answer cannot contain more sig figs than the measurement with the least number of sig figs. And this is because you're sort of bound by rounding your answer based on your worst measurement. Because even if the other one is very precise, has a lot of sig figs, when you start combining it in some sort of mathematical equation with the worst measurement, it's going to dilute the accuracy, the precision of the better measurement. And so you can only record your answer based on the lesser of the measurements with any sort of confidence, because if you try to record your answer based on the better, more significant measurement, you would be making a lot of unintended guesses at how precise that measurement is. So when we're looking at our numbers here, we have 40.8. That should read to us as being 3 sig figs. 15 is going to read as 2 sig figs. I typed it in the calculator. The calculator does not care about sig figs. It's going to tell me the answer is 612, which is 3 sig figs. But as I said, you can only be as precise as the lowest number of sig figs, which, as we've determined here, is 2. So that means my lowest, 15, is 2 sig figs. My answer will need to be 2 sig figs. So again, just reiterating here, my calculator tells me it's 612, which is 3 sig figs. But I need to get that to be 2 sig figs. So 612 will become 610. This 2 is the number that needs to get rounded. This 1 here will stay as a 1 since the 2 does not bump it up. It keeps it the same. And so I need to turn that into a placeholder 0. One important thing to note here is that some students will round this answer as 61, which is 2 sig figs. However, that is not the same number. 61 and 610 are not representing the same value. And so it's important that even though the 0 is not significant, that it is represented so that the number remains the same overall value. Again, referring to money, if you had $612 that you were owed and somebody was a little short and they're like, I'm just going to round it. Here's 610. Okay, you're missing $2. But if like, I'm just going to round it and they give you $61, you'd be very upset. You're missing like $500+ in that case. So in general, always round based on the lowest number of sig figs when you are rounding. We'll do a few examples from our notes pages here. Important piece of information is that the front part, when we look at a scientific number, is all we care about for sig figs. So this is 3 sig figs. This is 3 sig figs. These are important for typing them into the calculator, but they are not important for determining how many sig figs your answer should be. Since both of these are 3 sig figs, our answer should be 3 sig figs. Typing that into the calculator, we should get 1,310. Or sorry, 312.73. The first amount of sig figs are 1, 3, and 1. So I definitely need to keep those. Specifically, I keep the 1 because that's a 2, just like the problem before. It will not bump it up to a 2. It'll keep it as a 1 since it's less than 5. But I do need to have that placeholder of that 0. So I have 3 sig figs, but it's still 1,310. 73 here just gets chopped off because it doesn't change the value of the number. It would only add more sig figs. So this is my final rounded answer. Doing a few more down here that are below. First, most important thing is just figure out how many sig figs are in every number. So in this one, Notice that decimal there means that these trailing zeros count. This is 4 sig figs. All of these are non-zeros, meaning they all count. That gives us 5 sig figs. And then this one, also only non-zeros, is 2. So our final answer should end up being only 2 sig figs. Calculator answer is 47,786.76. Obviously, calculator is giving me a lot of sig figs. The first 2 sig figs I care about, 4 and 7. Then I look kind of over here at this next number, which is a 7. So unlike the last 2 examples I've given you, this number is above 5, which means it needs to bump that 7 up a digit. So instead of 47,000, it becomes 48,000. And then notice, I need to keep the place of these 3. So it's still 48,000, not simply 48. Very different numbers. But without putting a decimal, it's not significant. This is 2 sig figs because I have trailing zeros without a decimal. If I put the decimal there, then now I have 5. That's not what the problem wanted. But with only putting 2 numbers and then no decimal point, this is in fact 2 sig figs like I intended. I'll do one more example here where we have some leading zeros. So we have some division and multiplication going on here. We'll do this one down here. So this one, 2 sig figs. Here, these leading zeros don't count. So this is 1, 2, 3, 4, 5 sig figs. Leading zeros don't count here. 1, these trailing zeros do count because there is a decimal. So 2, 3, 4. Lowest ends up being 2 sig figs. Calculator answer on this one, depending on your calculator, it might give it to you in scientific or standard. So if it's in scientific, it'll be 6.80329 times 10 to the 5th, negative 5th. If it's standard notation, that would be 0 with 0.4 zeros and then the number. So if it comes up like this, etc., that's the same thing. So just whatever it spits out is fine unless I specifically say it has to be in scientific notation. But similar process. Our first 2 numbers, whether we're looking at it like this or like this, are the 0.68. So if I'm doing it in scientific notation, I'm basically just going to chop that off. This is a 0 here, so that becomes 6.8 times 10 to the negative 5th. Very important that we keep the exponent there, because otherwise I'm just writing 6.8, and that is not the number that it should be, because if we write it in standard notation and round it that way, if that's the way our calculator gave it to us, we would see that 6.8 would not be the same as that number. So again, either of these expressions of that number are fine unless it's specified it has to be a certain way. So the rest of them you can try on your own.